Welcome everyone to our statistics series. Today we'll be starting with the primary school aspect of it, first school leaving certificate, from our page 97 of hidden facts in primary school mathematics. Statistics is the aspect of mathematics that deals with gathering or collecting of figures, numbers in bracket. These figures or numbers are known as data about a particular place, people, object, thing, or issue, etc. It includes using the organized data for a given purpose. Let's take a pictorial diagram of a class where you have the teacher and the student. If the class teacher wants to know the weight of the students in the class shown above, it will start by weighing the first pupil in the first row, followed by the second pupil, then the third, and so on, till the pupil in the last row. As at the time of weighing the pupils in the class, the record collected, data in bracket, will look so scattered, not in order. Thus, any data collected and is unarranged is called raw data. At its convenient time, the teacher will now arrange the raw data in an orderly manner. In the case of ascending order, that is from lowest number to the highest number. In the case of descending order, from the highest number to the lowest number. Let's take example. Any information collected in the form of figure is called, options are given. Solution. Numerical figures collected are known as data. Let's take the next subheading, range. The next subheading, range. We may want to know how spread our data is. The range, among other terms, which will be discussed at a higher level, is used to determine spread. Thus, range is the difference between the highest number and the lowest number of any given data. Let's take some example on range. Find the range of the math test scores given below. In the first case, we have primary 5A. Our figures are given. We have primary 5B. The data are given for primary 5B. Solution. Range is the same thing as highest minus lowest. So for primary 5A, the range is 8 minus 2. 8 is the highest number in primary 5A, and that's the highest score in the math test. Then 2 is the smallest, hence that's subtraction, which will give us equals to 6. Primary 5B, the range is 9 minus 0, because 9 is the highest score there, and 0 is the lowest. The result is 9. Note that 0 is among the scores in primary 5B. Another example. The range of the set of numbers 47, 11, 26, 35, 54, 65, 82, 93, and 68 is, the options are given. Solution. Range is the same as highest minus lowest, which is equals to, in this case, the highest is 93. The highest number there is 93, and the lowest is 11, which will give us 82. Another example. What is the range of the following set of numbers? Minus 2, minus 1, 5, 0, 2. The options are given. Solution. Range is equals to biggest number minus smallest number. Here, the biggest number is no problem, but the smallest number among minus 2, minus 1, and 0 is the issue. And we know, so I've observed our number pattern, that minus 2 and minus 1 are smaller than 0, and minus 2 is smaller than minus 1. Thus, range would be equals to 5 minus, into bracket open, minus 2. And when we open up that bracket, it becomes 5 plus 2, because minus times minus is a plus, and that will give us equals to 7. Next, we take another subheading, other uses of statistical data. Here we'll be treating mean, median, and mode. At times, the center of a data is of concern to mathematicians and us alike. We use mean or median or mode as a measure of achieving it. That is, central tendency or as a measure of an average. Note that the average talked about here is a mathematics term, not the type you have been hearing about. So don't get confused. Let's take our first subheading under this, which is mean. The mean, that is arithmetic mean in bracket, the given set of n numbers, x1, x2, continue on and on to xn, is mean, which is x bar, is equals to, at the numerator we have x1 plus x2 plus continue on and on plus xn all over n. And is given, the formula is x bar equals to summation x over n, where the sigma sign is summation and n is the number of times. The mean here is arithmetic because the figures involved do not occur so many times. Let's take some example under mean. Find the mean of the numbers 2.5, 4, 2.8, 8.5, 4.2, and 2. Solution. Mean is equals to summation x over n, which is the same as, in this case, we have mean is equals to, at the numerator you have 2.5 plus 4 plus 2.8 plus 8.5 plus 4.2 plus 2 all over 6. And the result will be, when you add the numerator, you have 24. That summation of those numbers will give you 24 over 6. And that is equals to 4. Another example. The number of eggs collected by a poultry farmer from Monday to Friday are 28, 40, 52, 27, and 13. Find the average of the eggs collected. The options are given. Solution. Average is equals to summation x over n, which is equals to 28 plus 40 plus 52 plus 27 plus 13 over 5. The 5 here is the total number of data collected. There are 5 of them, which will give us 160 over 5, which is equals to 32. Another example. The ages of 6 boys are given as 12 years, 3 months, 18 years, 13 years and 7 months, 17 years, 2 months, 15 years, 14 years, respectively. What is their average age? The options are given. Solution. Let us arrange the ages out as, in a tabular form, we have years, then months. In the first case, we have 12 years, 3 months. In the second case, we only have 18 years. In the third case, we have 13 years, 7 months. And next, we have 17 years, 2 months, followed by 15 years, then next, 14 years. The total number of years will be 89. Then under months, you have 12 months, and that is 1 year. Now, you will observe from the table we have given that 89 years plus 12 months is equals to 90 years. Thus, the average year is equals to, our summation x over n will be equals to 90 over 6, and that is equals to 15 years. Next, we treat special cases of mean problems. Our first example there. If the average age of 6 boys is 14 years, find their total age. The options are given. Solution. Average is equals to summation s over n. In this case, we are to find summation x. Substituting into the given formula, we have 14, which is the average, equals to summation x over 6. We are be given the average, we'll be given the number of boys, which is 6. So here's the substitution. Then next we cross multiply to make summation s subject formula. So we now have that 14 times 6 is equals to summation x. Our result is 84 equals to summation s. Another example. The total ages of n students is 118 years. What is the average age of the students? The options are given. Solution. Average is equals to summation x over n. Here, summation s is equals to 118, and n is the same as n here. Thus, substituting average is equals to 118 over n. Another example. The average of the following numbers, 12, 20, m, 40, and 60 is 36. What is the value of m? The options are given. Solution. Average is equal to summation s over n. Substituting, we have 36, which is our average, is equals to 12 plus 20 plus m plus 40 plus 60 all over 5. The total number of data there is 5. Each of the data. That is to say 36 is equals to 132 plus m over 5. Next, we cross multiply. We now have 36 times 5 is equals to 132 plus m. That will give us 180 will be equals to 132 plus m. Collect like terms together. That will give us 180 minus 132 will be equals to m. And that's to say 48 is equals to m. Another example. The average age of 5 boys is 12 years. If one of them is 10 years old, what is the average age of the remaining boys? The options are given. Solution. First, we find the 5 boys' total ages. That is summation x. I will know from our formula that average is equal to summation s over n. Average is equal to summation x over n. In this case, substituting, we have 12 is equal to summation s over 5. Next, we cross multiply. 12 times 5 will be equal to summation s. And that's the same as saying that 60, the value 60 is equal to summation s, which is the total ages of 5 boys. The average age for the remaining boys, we still have it as average is equal to summation x over n. But in this case, our summation s will be 60 minus 10, which is equal to 50. And n will be 5 minus 1, which is equal to 4. Thus, average here, average in this case will be equal to 50 over 4, which is the same as 25 over 2, which will give us 12 whole number, 1 over 2 years. Or you interpret it this way as 12 years, 6 months. We've come to the end of the examples under this subtopic. Next, we have some exercises taken from the Hidden Fact in First School Living Certificate, which is the primary school aspect of it. Page 97, 98, 99, and 100. The answers are there at the hard copy of the book or the soft copy. Thank you.